Hello viewers, let's learn algorithm design today. It's fun to learn. It's very simple. A computer does not have intelligence of its own. It will not do anything that it has not been instructed to do. Or in simple words, we can say a computer will do only what we tell it to do. Algorithm is a finite set of well-defined instructions to carry out a task in order to get a desired result. Finite set means it should have clear start and end points. Well-defined instructions means there should not be any confusion. Each step should be explicitly stated, specifying what operation or actions are needed to be performed and in what sequence. Truly speaking, we all humans already have an intuitive understanding of algorithm. Still gaining a deeper understanding of this will surely improve our algorithmic thinking. Correct algorithm is the ultimate basis of any computer-based solution. The final goal of problem solving using computational thinking is to be capable of developing or designing instructions, solutions that a computer can execute. While writing algorithm, one has to focus on clarity and precision. Algorithms have several properties. First is collection of individual steps. Algorithm is collection of clearly defined individual steps. For example, let us write an algorithm for our morning routine. Get up at 6 a.m., brush your teeth, finish breakfast, right? This is the algorithm which you have written. This is very short. In between, if you are performing more tasks, you can add to it. But this is it is a collection of clearly defined individual steps. Second property is definiteness. Definiteness means that every step must be precisely defined. Each step in an algorithm can have one and only one meaning. Otherwise, it is ambiguous. For example, I need to fill up the bottle. The literal meaning of this is the bottle is empty and it should be filled with water or any other liquid. But the figurative meaning can be I need to gather more energy, motivation, or inspiration. If you are saying this to a friend, then your friend can easily understand the context in which it has been said and can understand or capture the right meaning of this sentence. But you cannot expect this from the computer. Computer has its own limitations. While writing these steps, you have to be very careful that they should carry one and only one meaning. The next property is sequential. Algorithms are sequential. That means all the steps which are written in an algorithm, they are to be executed one after another in the specified order. If we fail to do this, then after executing the algorithm, the probability of getting incorrect result is 99.999%. For example, if you are writing an algorithm like brush your teeth, get up at 6 o'clock, finish breakfast, like whatever is coming in your mind, you are writing one after another, how to do this, so you are just writing it down. This is not the way the algorithm is written. We must respect the sequence so that while running the algorithm, we should get meaningful result. Next is controlling algorithm execution. At a basic level, they can be used in two ways. One of those is iteration, which is also known as looping. Iteration allows us to repeat a series of steps over and over. We can define iteration as it is a process of repeating set of instructions or a block of code multiple times. It allows us to perform same set of actions repeatedly until a certain condition is true. That is for a specified number of iterations. In programming, iteration is often achieved using loops. There are two commonly used loops, for loop and while loop. Let us take this example. Teacher has given you task to write these two lyrics repeatedly till 1 cup of ice cream is left in the fridge. So you have to write 10 cups of ice cream left in the fridge. Take one out and pass it around. And then how many cups will be left? 9. So you have to write 9 cups of ice cream left in the fridge. Take one out and pass it around. Like this, you will have to repeat till last ice cream is taken out. Let's take a variable x for storing the number of ice cream cups. That means we will assign a value 10 to x because 10 is the number of cups initially we have. And then display these two lines. So instead of x, 10 will be displayed. 10 cup of ice cream left in the fridge. Take one out and pass it around. And after executing these two, now we will assign x minus 1 to x. Now with this, what will happen? The x will have one memory cell and there the value 10 will be stored. Now when you are assigning x minus 1, now it will be 9. So 9 will be assigned to x. First of all, the x was holding the value 10. Now because you have assigned new value to it, that 10 will be overwritten with the new value 9. And then you repeat this process till x is greater than 0. Each time x will be decremented by 1, so it will become 8, 7, 6, 5, 4, 3, 2 and last will be 1. So when 1 will be assigned to x, still it is greater than 0 and therefore it will go back and 1 cup of ice cream will be taken out from the fridge. Now when x minus 1, that means it will become 0. X will have value 0 in end. So it is not greater than 0, it is 0 now. And therefore finish, come out of the loop. Now the next is selection. To control execution of the loop, we have already used the condition. It can be used at any stage in the algorithm. Not only to control loops, wherever they are, they all serve the same purpose. Creating a point at which the computer has to decide between the actions to be taken, which particular steps are to be performed next. That decision it has to take. Let us take one example. Teacher has given homework that you have to finish, but your mom has given you the condition that if you finish the homework, then only you can go for play. Write a condition that you read the input, homework finished, and you are supposed to answer in Y, that is for yes, and N for no. So if now you are writing the condition that if homework finished is yes, Y, then display you have finished your homework, go and play. Otherwise, display you need to finish your homework before you can go and play. This is how you can make use of selection. These aspects of reasoning are important in computational thinking because computers are involved. This was the example for one condition. It is our responsibility to make sure that the reasoning should produce the correct result. One condition was given. If that condition is true, then do this. Otherwise, do this. Now you can combine multiple conditions using logical operators. At this point, let us learn logical operators and let us see how will they work. AND operator. AND operator helps us to make decisions based on multiple conditions. Just like we consider different things before making a choice, isn't it? How do we use AND operator in our algorithm? AND operator connects two or more conditions and checks if all of them are true before giving a thumbs up. So if all the conditions are true, then it is true. Otherwise, in all other cases, it will yield the false result. The truth table of AND operator you can see on the screen. It is clearly stated here that if condition A and condition B and condition C are true, then only the result will be true. Otherwise, in all other cases, it is false. You can see there it is written A ampersand ampersand B ampersand ampersand C. In most of the programming language, the AND operator is depicted like this. So that is A and B and C. If all these three conditions are true, then only the result will be true. Otherwise, false. Let us take one example. Imagine you want to make sure that this year you are trying to get the best student award. And there are three conditions. You must score 90% and above. You must represent school in at least 2 games, that too in state level tournament, and your attendance should be 100%. Using AND operator, we can combine these conditions. If condition A is true, and condition B is true, and condition C is true, then you are eligible for Best Student Award. Otherwise, you will display that you are not eligible for Best Student Award. The importance of AND operator is that it helps us to set multiple requirements or conditions before making decisions. It also ensures that everything aligns perfectly, just like in our example, where a student needs to meet all the criteria for being eligible. The next is OR operator. In OR operator, it is like a magical gateway. It opens options for us. It connects two or more conditions and checks if at least one of them is true. It checks at least one of them is true before giving a green light. So you can see on the screen, it is false when all the conditions are false. Otherwise, it is always true. So if any one of the condition is true, then it is going to yield true result. OR operator will return true if at least one of the option is true, and when all the options are false, then only the result will be false. OR operator only requires one true condition. Only one condition should be true, then it is true. If all of them are false, then it is false. Let's take one example. Imagine a child has been promised a special prize if he or she completes all or any two or any one of the following three tasks within an hour. Task A is clean your room, task B is finish homework, and task C is practice a musical instrument. Using OR operator, you can combine all these options. So if option A is true, or option B is true, or option C is true, then the child will get a special prize. The importance of OR operator is it broadens our decision-making possibilities and allows us to have more flexibility in choosing from different alternatives. The outcome is we have started with computational thinking. The goal of problem solving using computational thinking is to be able to develop a solution that a computer can execute. See, computer doesn't have any intelligence of its own, so it won't do anything that it has not been instructed to do. The reality is that the computer will do only what you tell it to do. Algorithm has two properties which are very essential: well-defined steps and finiteness. With this, we are moving forward in this series. In next video, we will take hand-on approach and practice writing fundamental algorithms from scratch. I'm really excited to embark this practical journey with all of you. In next videos, get ready to write, learn, and conquer algorithm design. We will meet again in next video. Have a good day. Thank you.